All right, good evening, ladies and gentlemen. At least it's evening for me here. We're going to do a video on section 3.5, and we're going to try and make it a quick one because I don't want you to have to watch this video and watch my voice or listen to my voice for that long. So section 3.5 is on this goal. So why don't you write down that goal right away? And you can see there's triangles there, so it actually is going to have to do with triangles. But the goal is I can use theorems and prior knowledge to find angle measures. Okay, we're going to have a couple new theorems and then prior knowledge of other angles and things about triangles. Got a little fun little picture about Chuck Norris on there. If you look at it, you'll think it's funny. But anyway, we're going to start with some theorems, and these theorems, I believe, are all in your notes. We'll go through a couple of them and we'll apply them. There's some really good examples in the section. Some we'll go through, some we will not. But the first postulate. So the first postulate we have is the second postulate for the chapter. It can go on your theorem sheet, but it's called the parallel postulate. All right, it says through a point not on a line. So if we have our line L and a point not on our line would be point P, there is one and only one line parallel to the given line. So in other words, if you have a line L here, that's my red line here, and if I make a point, I'll make it green now. There's only one line that can go through that point and be parallel to line L, and that would be this line right here. Okay? You might need to use that later on. And then the theorem 3-11, this is your 11th theorem. It's called the triangle angle sum theorem, and this is something you definitely have known already. But it is a theorem. The sum of the measures of the angles of a triangle is 180, and it should be 180 degrees. Okay, so the measure of angle A, B, and C would add up to 180 degrees. So let's see what we can do with those theorems, particularly the second one right here. All right. Examples 1 and 2. So example 1, first of all, we have a triangle. We have three angle measures labeled. Remember, they all add up to 180 degrees. We just said that. So we can do our x plus our 6x plus 10 plus our x plus 2. And you know, since it's all addition, we don't technically need those parentheses. That's from the associative property of addition you learned ways back. But so we can just combine like terms then. We have x, 6x, and another x. That would be 8x total. And then our 10 and 2 would get us 12. Still adding up to 180. Solving your two-step equation gets you to 8x equals 168. And then divide both sides by 8. And you end up getting x equals 168 divided by 8 is 21. So x is 21. But it's actually asking us to find the angle measures. So to find the angle measures, if x is 21, this angle should be easy. This is 21 degrees. X plus 2, that's 23 degrees. And then plug in so 6 times 21 would be 126. Plus 10 would be 136. All right, so that's 136 degrees. All right, one more example over here with just some angle measures. Looks like we have two triangles stuck together here. These right here would be vertical angles, so that's something good. But right here. So angle 1 we could figure out because the measure of angle 1 plus 28 plus 82 would be equal to 180. So the measure of angle 1, we'll skip ahead, is equal to 180 minus 82 and minus 28. So that would be minus 110, so that would be equal to 70 degrees, I think. So I think our angle would be 70 degrees. So that's the measure of angle 1. And that means the measure of angle 2, since those are vertical angles, is also 70 degrees. Let me just have one more to label. So 70 degrees there and there. So then the measure of angle 3 would be equal to 180 minus 68 minus 70. So that would be minus a total of 138. So I think we're left with 42. So the measure of angle 3 is 42 degrees. Okay, if you need to take a step back and pause the video and check how we got those, please feel free to do so. But otherwise, we're going to move on to the next theorems. Actually, we have a vocab term here first. This is important. It's actually the exterior angle of a polygon. This is actually one of the vocab words for the chapter. It's an angle formed by a side of a polygon, and we're going to deal with triangles here, and, an extension of the adjacent side, or of an adjacent side. So for instance, all these red angles are called exterior angles. It's just like you're extending one of the sides, and that creates an angle there. That would be an exterior angle. That would be an exterior angle of a polygon. Now here's something too. For each exterior angle of a triangle, the two non-adjacent, so not next to it, interior angles, that would be, leave this one and this one, would be called remote interior angles. So those would be both of these. Same thing, it's angles 2 and 3 for each of those. And that gets us into a theorem here. Theorem 3.12 is the triangle exterior angle theorem. The triangle exterior angle theorem states simply that the measure of each exterior angle of a triangle equals the sum of the measures of its two remote interior angles. So the measure of angle 1 in this picture is equal to the measure of angle, the two ones that are not next to it, the non-adjacent interior angles, which would be the remote angles, would be the measure of angle 2 plus the measure of angle 3. So that's an interesting thing there. And you can kind of prove that. We might prove that at some point, because if you look right here, these would be, those two would be supplementary. So those would add up to 180, and that means that angle 1 and angle 2 and 3 would also add up to 180. So, or sorry, those would be equal since the interior one would add up to 180 with 2 and 3. But anyway, we have 1, 2, 3, 4, 5 examples that we're going to use with these theorems that we've done so far. And I'll go through a few of them. I won't go through all of them, maybe 3 of them. The other 2 I want you to do on your own. But let's just start with the first one directly from this theorem. We know that measure of angle 1 is going to be equal to the sum of the two interior angles, the remote interior angles, which would be 99 plus 30. So the measure of angle 1 is equal to 129 degrees. Okay, directly from that theorem. Now we're going to do some, we'll set up number 2. Number 2 is very similar, except we have that exterior angle, so we have that 48.3. That's going to be equal to the measure of angle 2 plus 26.8. I'll leave you to solve that one for the measure of angle 2. Let's do number 3 and then number 5. All right, so number 3. We need to find measures of angles x, y, and z. So let's see. Well, we could label this. This would be a right angle then 2. Well, then we could do y, because y would, the measure of angle y plus 61 plus 90 would make that whole 180 degrees inside of that left triangle. So if you subtract 90 and 61 from 180, you end up getting the measure of angle 1 is equal to 29. All right. Looks like we could do the measure of angle x too. If this is a right angle there, so the measure of angle x would be equal to 90 minus 61. That's also equal to 29 degrees. Interesting. Then we just have to do z. So if x is 29, and we have, this is a right angle, then we can do the measure of angle z equals 180 minus 90 minus 29. And that one will also be 61 degrees. Very interesting how that works out. All right, this last one is a thinker. So you got a lot going on here. We have measure of angle 1 to find, measure of angle 2 to find, measure of angle 3 to find, measure of angle 4 to find, and the measure of angle 5 to find. Let's just quick check our time. Let's see if we can get through this whole thing and still keep it short. All right, we're at 10 minutes. We can get this done in a couple minutes. So, all right, here we go. Well, is there anything right off the bat you can tell? Now, we do have it labeled that these two lines that look parallel are truly parallel. We have those arrows there. So that's good. We can look at some transversals. So I'm going to look at this one. This is an alternate interior angle with angle 3, so those would be congruent. So the measure of angle 3 would have to be 60 degrees. Okay, that's good. Measure of angle 3 and 4 then are a linear pair, so those have to be supplementary. So this one would have to be 180 degrees minus 60 degrees. So that would be 120. Good. We've got 2 already. Oh, same thing with angle 1. That would have to be 180 minus 135, which would be 45. So angle 1 would be 45 degrees. Oh man, we're cruising. Because look, this angle 1 and angle 5 would have to be, those are also alternate interior angles, so those are congruent. So this would be 45 degrees as well. Let me just have one more. So the measure of angle 5, 2, and then that 60, this would all make one whole 180 degrees. So if we do 60 plus the measure of angle 2, which is, well, measure of angle 2 plus the measure of angle 5, which is 45, that should equal 180. So we subtract 105 from 180, and you get the measure of angle 2 equals 75 degrees. So that'll be right there. So I know I went through that pretty quickly. That's just my thought process, looking for which angles would be the easiest to find right away, and it led me to a lot of other things that actually helped out. It pays to know your angle pairs, and it pays to know your theorems, though. All right? So on your own, you can do this error analysis question and answer the closing question, and be prepared to do some additional work on this next time in class. All right, thanks for watching. Have a good one.